Okay, now we'll learn the algebra of complex number. Algebra of complex number. Okay, so there will be some addition property, then subtraction property. Addition, first is addition. Suppose we have to add two complex number. Okay, suppose we have to add two complex number. Addition. Let I'm representing two complex number with z1 and z2. Okay, representing with z1 that is equal to a a1 plus I b1 and z2 is equal to a2 plus I b2. Okay, so there is two complex number, you can see. There is two complex number and we have to add this complex number. Okay, how to add these two complex number? So addition will be, so I'm representing this number again with another number. Suppose z equal to z1 plus z2. Okay, z1 equal to z1 z equal to z1 plus z2. So replace the value of z1 and z2 plus, look, in z1 a1 is the real part and b1 is the imaginary part, right? Similarly in z2 a2 is the real part and b2 is the imaginary part, right? So when we'll add this real part will be added with real part. Okay, real part will be added with real part, so it will be a1, it will be a1 plus a2, then plus it will be I b1 plus I b2, b1 plus, okay. So always real part plus real part and imaginary part plus imaginary part. Now in imaginary part you can see we can take common I from here, so ultimately it will be where outside will be I and we are just taking common the I, okay. From here if you just take common the I, you will get a1 plus a2 plus I into b1 plus b2. So what you can see, always we have to add the real part together and the imaginary part together, okay. Similarly, so let me discuss some properties of addition. Property number one, you can say first property known as closure property, closure law. If z1 and z2, if z1 and z2 are complex number, then z2, so it's saying that if z1 and z2 are complex number, then z1 plus z2 is also a complex number, right? You can see this one from here. Look, here we made z1 was a complex number and z2 was also complex number, and look, z1 plus z2, what we got, a1 plus a2 plus I b1 plus b2, okay. So if z1 is z1 z2 is complex number, then z1 plus z2 will also call also complex number. Next is commutative law. Commutative law. What this law is saying? This law is saying, this is very normal. Z1 plus Z2 is equal to Z2 plus Z1. Okay. So this is, I mean, all of you know how to write Z1. If someone 5 plus 7 is always equal to 7 plus 5, right? So that is the thing. Okay. Next is associative law. Associative law. Look, now you will have like more and less basically MCQ type question maximum. So knowing this kind of law is very important, because sometimes this question can come, I mean, as a MCQ, the which law associate, write down associative law like this. Then z2 plus z3, which is equal to, we can write, plus z2 plus z3. Okay, this is also quite well known, that z1 plus z2 in first bracket plus z3, this will be same as z1 z2 plus z3. Okay, then number 4, subtraction, sorry, existence of the existence of additive identity. What this mean? This mean, look, every complex number can be written as z plus 0 equal to z, right? If you add anything, if you add 0 with any complex number, it will be same the complex number, right? So this is the thing. This is called existence of additive identity. Existence of additive identity. If you add 0 to any complex number, it will be the same complex number. Then last is the existence of additive inverse for every complex numbers z equal to a plus ib, there is there exists minus z equal to, in bracket, minus a plus I in bracket minus b. Okay, so it's saying that for every, this is called additive inverse. Additive inverse means what? Suppose for z there is another minus z, so if we add these two, it will be 0. Okay, so for every complex number is saying, for every complex number there is exists minus z, which is minus a plus I into minus b. Okay, so this is the few things about this. Next we move on to the subtraction subtractions subtraction. How to do the subtraction? Let's copy this one and same thing. Okay, subtraction is like z1 equal to a1 plus ib and z2 equal to a2 plus ib. So subtraction z1 minus z2 will get minus and minus. Okay, so z1 equal to a1 plus ib1 and z2 equal to a2 ib2. So it is minus. So as I told here also it will be real versus real. So a1 minus a2, then plus I common it will be b1 minus b2. Okay, plus I common it will be b1 minus b2. So here also subtraction also same thing, that real part minus real part and imaginary part minus imaginary part. This is our subtraction. Subtraction also 2 3 there is one, there is no such like properties. Okay, but for let's discuss the multiplication. Discuss the multiplication. So in multiplication, so similarly here also z equal to a1 plus I b1 and a2 z2 equal to I b2. So z equal to like z1 z1 multiplied z2. Okay, so just put the values. So now we have to multiply like a class 9 multiplication. Okay, what to do? A1 a2, right? First number will be a1 a2. It will be a1 will be a2, right? A1 multiplied with a2, so it will be a1 a2. Then a1 multiplied with ib2, so it will be plus I a1 b2, right? Then plus I, now b1 ib1 will a2, right? So it will be ib1 ib1 a2 a2 plus now it will be ib1 into ib2, right? So it will be I square. Why I square? I into I square. Then b1 b2 b1 b2. Okay, now if you simplify this one, we'll get all this, everything you will get from this two. I'll take I common, so I can write in bracket and we know I square value is what? I square value is minus 1, right? So it will be minus. So if you rearrange this one, this thing again, it looks like if you rearrange this one, it looks like A1 A2 minus B1 B2. A1 A2 minus B1 B2, this is 1, and plus I A1 B2 and A2 B1. Okay, this is our product. Whenever product is there, we have to do like this. We have to just follow this rule, that real part and the imaginary part, they will subtract the real part into real part, okay, minus the imaginary part into imaginary part. Then, or otherwise you can generally follow the rule of multiplication, you just follow, or you can use this formula. Okay, this is very important. Okay, so now you can see the last portion, that is constant, sorry, division. Okay, last will be division. There is some rules, properties of multiplication later I will give. Okay, that is not that much important. That is like the addition one. Like last is division. Okay, division also same. So in division it will be division sign. Okay, so division equal to, we can write can I write this one next line, z1 divided by z2. Next line I'm writing z1 into 1 by z2, right? So basically division is another type of multiplication. Okay, so for division we always have to do like this, z1 into divided by z2, so z1 into 1 by z2. We'll find this one, then we'll multiply like this before. Okay, so this is our almost and before going to the exercise, we need to know few more things. Conjugate I will later. Okay, there is few formula is there, that is few formula, identities, identities related to complex numbers. Okay, so these identities all of you know almost. that is a plus b whole square formula, these formulas. Okay, first is z1 plus minus z2 bracket. Okay, that is z1 square plus 2 z1 z2, sorry, plus z2. Okay, so check this one. What I wrote here z1 plus minus z2 whole square. What does that mean? My goodness, that mean either z1, this is like a plus b whole square formula. In a plus b whole square or a minus b whole square, look, z1 square and z2 square, they will remain same, but only thing is that plus or minus z1 z2. Okay, so whenever this will be this, then write like this, z1 plus z2 square will use the plus, when z1 minus z2 will use the minus sign. Okay, similarly number 2, number 2 is z1 cube plus minus z2 to the power 3. Okay, plus minus 3 z1 and z2 plus 3 z1 z2 square. Okay, so this is the whole cube formula. All of you maximum if you know a plus b whole cube formula. Then this is a square minus b square formula. This is z1 minus z2, which is equal to z1 plus z2, z1 which is equal to z1 plus z2 and z1 minus z2. Okay, so this is the few identities we know. Okay, so now we can move towards the our exercise. Okay, we can go to our exercise problems. So last part modulus and conjugate is left, but still okay, we'll do later that. We'll do some problems of from exercise. If still any doubt, please let me know. I don't think I just discuss all the theories and like properties only today. Okay, so exercise page number 109. Open exercise 5.1, question number 1. So from 1 to 10, the question given, we have to express each of the complex number given 1 to 10 in the form. Oh, we have to only, we have to express only a plus ib form, right? So first complex number, write down. First number is 5i, then minus 3 by 5i. Okay, so we have to let's do, we have to write in a plus ib form, right? So from here you can see 5 and this 5 will cancel. Okay, so it will be I into minus 3i. Okay, so ultimately it will be minus 3i square, which is equal to minus 3 into minus 1. I square means minus 1, which is equal to 3. Okay, so 3 equal to what we can write? 3 plus I into 0, right? 3 plus I into 0, that is our required complex number. Then next question number 2 and 3 I'm not doing. I'm giving you homework. Okay, 3 I'm doing. I sorry, 3 I'm doing. Let's see. Question number 3 I'm doing. Other will be homework. I will minus 39. So how to express this one? Minus 39 equal to, we can write 1 divided by I to the power 39, right? Then I told how to do 1. So what is the nearest number of 39, which is multiple of 4 and greater than 39? Let me know the number which is multiple of 4 and greater than 39. Which number? Which number is greater than 4? Okay, I did not knew this one. Okay, you are just informing now, so it's okay. It's almost finish, about to finish the today's class. So like I did not got any information like this. Okay, it's okay. I can see now. I was, so it's okay. I don't think it will be if I take only 2 3 problems, I don't think it will be much more problem. I already yeah, I already today I already as today I already started the class, so better to end in a good way, right? Not to end in the middle, right? So I'll do another 2 3 problem. Okay, then after the class I'll let you go. Okay, I'll tell this one to principal also, because I did not knew this one before. So yeah, why what I was asking that, uh, tell me a number which is greater than 39, nearest 39, and multiple of 4. Fast, fast. If you cooperate, it will be fast. Okay, otherwise it will take time. If you cooperate, it will be less time. So let me know the number. Nearest 39 and more than. It will be 40. I am talking about more than. So I to the power 40 value will be 1, right? And I to the power 39. If you simplify this one, it will be value will be I. Okay. So I will be written as, we can write 0 plus I into 1. Look, in this question number 1 to 10 is question asked that you have to write in a plus ib form, right? So whenever you got the answer, you have to write like this: 0 plus I into 1. Similarly, 3 plus I into 0. Okay, okay, let me do difficult questions some difficult question. Let's see. Okay, question number 4, not that difficult but still doing. Plus 7 plus I7 plus I7 plus I7. Okay, how to do this kind of question? Just in this kind of question, you have to just multiply this thing. So 3 into 7 is 21 plus 3 into 7, 21. So it will be I 21 plus 7 into I is 7I plus I into I square. So it will be I square. Okay, 7I square, right? Then equal to 31 plus to I21 and 7I. If you add these two, it will be I28. Okay, and I square means minus 1, so it will be minus 7. If you simplify this one, it will be 24 plus I28. This is as simple as that. Okay, then after this I'm doing question number 8. Question number 8 and 10 I will do last. Last question will be 10. 1 minus I to the power 4. This question. So in this question we can write this one like 1 minus I square, right? 1 minus I to the I whole to the power 4. So I can write 1 minus I whole square, then bracket another whole square. Okay, sir, 21 not 31. Or is 31? Which one are you talking about? Oh yes, yes, this will be 21. Sorry, sorry. 3 into 7 is 21. Sorry, this is 21. Thank you. This is 21. So 21 minus 7 will be 14. 14. Yeah, true. It is 21. To look, this is one mistake I did. 3 into 7 is 21. So it is 21. 21 minus 7 is 14. Okay. So next line inside the bracket. What is a minus b whole square formula? We just learned the formula. Z1 minus Z2. Okay, Z1 square plus Z2 square minus 2 Z1 Z2. Okay. So it will be Z1, which is 1 square plus z2, which is I square, minus 2 into z1 into z2 inside the bracket. If you simplify this one inside the bracket, it will be 1 minus 1. Look, 1 square 1 and I square is minus 1 minus 2i. If you simplify again, 1 and 1 will be cancelled. 1 and 1 will be 0. So ultimately you will have minus 2i square. So it will be equal to minus square, it will be 4i square. So it will be 4 into minus 1. It will be 4 into minus 1. So answer will be minus 4. Okay. Okay. So today's last question, as I told, question number 10, minus 2 minus 1 by 3. Okay, so here you can see what we will use. We'll use a minus b whole cube formula, right? What is a here? What is z a here? Minus 2. And what is b here? 1 by 3i. Okay, don't forget. Okay, so formula a minus b whole cube formula is, let me write the a minus b whole cube formula first. A minus b whole cube formula is a cube minus b cube minus 3 a square b plus 3 ab square, right? This is the a minus b whole cube formula. Okay, so similarly same thing will apply here. Minus 2 whole cube minus, what is b? Don't forget here b is 1 by 3i, not minus 1 by 3i. Okay, here a is minus 2, b is 1 by 3i, and this is minus sign. So it will be 1 by 3i whole cube minus 3 minus 2 square into 1 by 3i plus 3 into minus 2 1 by 3i. Okay, fine. So then if you simplify this one, minus 2 whole cube will be minus 8, minus 1 to the power, this will be minus 1 divided by 3 cube. 3 cube means 27, and I to the power 3. Then minus 3 into minus 2 square is 4 into 1 by 3, into 1 by 3i. Okay, plus 3 into, it will be minus 3. Why? Look, minus 2 is there, so it will be minus 3 into 2 into 1 by 3 I. So let's see what we can cancel from here. These 3 and this 3 will cancel. Okay, and here these 3 and these 3 cancel. So next line it will be equal to minus 8 minus 1 by 27. What is the IQ value? IQ value is minus I. Okay, later you just simplify by yourself. Then minus. Here it will be 4I. 4I. Okay. Okay, one mistake I did here. It will be minus 1 by 3 square. Right. AB square. Right. So it will be 1 by B square. So it will be 1 by 9 I square. Right. 1 by 9 I square. Okay, this one my mistake. So 3 and here, so it will be 3 3 cancel. Next line it will be minus 3 and this will cancel, so it will be 2 by 3, right? Because 3 into 3 9, and I square is value is minus 1. So next line again it will be minus 8. Okay, then minus minus plus, it will be 1 by 27. It will be 1 by 27 I minus, sorry, minus minus plus, so it will be plus sign, minus minus plus, and it will be minus 4I. It will be minus 4I. Okay, then plus 2 by 3. Okay, because minus minus plus. Then next line, if you simplify this one, you will get minus 3. I'm adding this 2. Okay, 3 into this will be 24 minus 2 plus, if you take I common, it will be 1 by 27 minus 4. Little big simplification, so it is minus 22 by 3. Okay, plus I, it will be 27 1 minus, okay, calculation, later you just check this calculation. For calculation purpose, you just check the calculation later. Okay, I think it's correct. So it's okay. Our today's class is up to this. And now please write down your roll numbers, or if anyone have doubt, please let me know. Write down your roll numbers, please. Thank you so much for the wishes. I'm getting so many wishes. 1, 11, 11 is 11 लिखूंगा. अच्छा 11 was absent. 11 was absent. 11, 19, 15, 21, 4, 9. After giving the roll numbers, please you can leave. Okay. Don't forget the roll number. This one okay, 12, 17. Okay, fine. If you want roll number.